Hi, I'm Miss Hearn. Let's get started. If you find this video helpful, please remember to give it a like. That helps other students to find the video. In this video, we're going to answer a question that one of my students sent me from my math lab. This question comes from Mathematical Ideas by Miller, Hornsby, and Heron. And it goes like this. In Euclid's proof that there is no largest prime, a number can be formed by taking the product of primes and adding 1. The number 30,031 can be formed in this manner. Is 30,031 prime or composite? If it's composite, give its prime factorization. So when we're checking to see if a number is prime, you have to check all the primes less than the square root of the number to see if they divide evenly into it. It's not necessary to check any primes larger than that. So what we're going to do is take the square root of 30,031, the number we're interested in, which is about 173.29 if you check on your calculator. So we need to check to see if this number is divisible by primes less than 173.29. So what I'm going to do is I'm going to start by using the Sieve of Eratosthenes, which is just a method of process of elimination determining what numbers are prime. Start with the first prime number, which remember 1 is not considered a prime, so we go directly to 2. So I'm going to cross off 1, that's not considered a prime number. I'm going to circle 2. 2 is prime because it's divisible only by itself and the number 1. Those are the only two numbers that go evenly into it. Now, any other number divisible by 2 is by definition not prime, so you can immediately cross off all even numbers, all multiples of 2. So we're going to cross off 4, 6, 8, 10, 12, 14, 16, 18, and so on. All the way up to 158, 160, and 172. All right, so each time you find a prime, you're going to circle it and cross off all of its multiples because we know those can't be prime. And then whatever the next number is after that prime, like in this case, the number 3, this must be prime as well. And it is, right? Only 1 and 3 can divide evenly into it. So then this is a prime, and we're going to cross off any multiples of 3, like 6, but that's already crossed off. But we can cross off 9. We can cross off 12, that's already crossed off. We can cross off 15. 3 more than 15 is 18. 3 more than 18 is 21. And we're going to continue in this manner, crossing off every third number. In other words, every multiple of 3. Continuing all the way up to 156, 159, and 171. So I've crossed off all the multiples of 3. Now we're going to look at the next number that's neither circled nor crossed off, which is going to be 5. And for 5, we're going to circle it. That's a prime, right? Only divisible by itself and 1. And so we're going to cross off all multiples of 5. Now the multiples of 5 are easy to cross off because it's all the 5's column and the 10's column. So here I've crossed off all the multiples of 5. The numbers ending in 5 and 0. And now we're going to move on to the 7. So I'm going to circle the 7 and cross off all the multiples of 7. So every 7th number. So if you were to count 1, 2, 3, 4, 5, 6, 7, you get to 14. 1, 2, 3, 4, 5, 6, 7, you get to 21, which is 3 times 7. 1, 2, 3, 4, 5, 6, 7, you get to 28, which is 4 times 7. 1, 2, 3, 4, 5, 6, 7, you get to 35, which is 5 times 7, and so on. All the way up to 133. 7 more than 133 is 140. 7 more than 140 is 147. 7 more than 147 is 154. 7 more than 154 is, and oops, found an error. I was missing a line there, so I filled that back in. So sorry about that. 154 I've crossed off as that's a multiple of 7. 7 more than 154 is 161. 7 more than 161 is 168. And 7 more than 168 would be 175, but that's off of our chart. So now I'm going to go back to the beginning. And so hopefully you get the idea how the Sieve of Eratosthenes works. You would continue in that way. But before we continue, I just want to check to see if any of these numbers divides evenly into 30,031. Because remember, we're trying to determine if that number is prime or not. So we are going to check 2, 3, 5, and 7. It's not divisible by 2, I can tell looking at it, because it doesn't end in an even digit. So that's a no. Okay, it's not divisible by 3. You can divide it on a calculator to check and you'll get a decimal place. Or remember our divisibility test for 3. You add 3 plus 3, well, 3 plus 0 plus 0 plus 3 plus 1 equals 7. If that number is divisible by 3, we have divisibility, but we don't. So this is a no. I know it's not divisible by 5 because it doesn't end in a 0 or a 5. And so now let's check 7. So the way that I'm going to check if it's divisible by 7, there's not an easy divisibility test for 7. So I'm just going to go 30,031, divide that by 7. And see how it's a decimal? It doesn't go in evenly. So that means that no, it's not divisible by 7. So again, we're checking for divisibility. And so none of those primes worked. So we're going to go on to the next prime number. All right, so the next number that's not been circled is the number 11. So we're going to circle 11 and cross off all multiples of 11. So there's 11, 22, 33, 44, 55, 66, 77, 88, 99, and so on, crossing off every 11th number up to and including 165. So let's check if we have divisibility by the number 11 now. I'm going to just use my calculator. 30,031 divided by 11 equals, and it's definitely not a whole number, so this is not divisible by 11. Let's see what the next prime number is. The next prime number on our list is 13. All right, so 13 is circled, and then we cross off all multiples of 13. So like 26, 39, crossing off all multiples of 13 up through the number 169. And now let's divide by 13. 30,031 divided by 13 is not a whole number. The next prime number on our list is going to be the next number that's not marked off, which is 17. And then we're gonna get rid of any multiples of 17. So let's go ahead and check to see if our number is divisible by 17. So I'm going to divide 30,031 by 17. And it is not divisible by 17. So we check the next prime, which is the next number not crossed off, which is 19. Crossing off all multiples of 19. Now let's divide 30,031 by 19 to see if it goes in evenly. So 30,031 divided by 19 is not a whole number. So we go on to the next prime. So here I've continued the process and found the primes 23, 29, 31, 37, 41, 43, 47, 53, none of which divides in evenly. Going back up to our table here, I just want to show you one more, which the next number that has not been crossed off is 59, so that's our next prime. I just want to show you how it gets easier and easier to use the table, because 59 is almost 60, right? So if we were adding 59 to this, that's like 60 minus 1. Every 10 is one row, so 60 would be 10, 20, 30, 40, 50, 60 more than 59, but we want 59 more, so we go one less than that. So that's going to be 118. And then we're going to go again almost 60 more than that. 1, 2, 3, 4, 5, 60 would be at the next row, one less would be over here. We're not even going that high, so there's only one to cross off at that point. And then if you check 59, 59 does divide in evenly. 30,031 divided by 59 is 509. So what we just found is that 30,031 factors into 59 and 509. And so we now know that this is definitely a composite number. And we were asked in the question, if it is a composite number, to write its prime factorization. But this reduces our problem down to finding the prime factorization of 509, and we only need to check primes up to the square root of 509 in order to determine which might divide evenly into it. So the square root of 509 is about 22.6. So we need to check any primes less than 22.6. Well, we already have a list of primes less than 22.6. 2, 3, 5, 7, 11, 13, 17, and 19. And we already know those numbers don't divide evenly into 30,031, which means they cannot possibly divide evenly into one of its factors, 509. So we can conclude that this does not factor further. So, and you could check, you can divide in 2, 3, 5 through 19 and see that they don't divide in. But if they were to divide 509, they must have divided the original number, and that didn't happen. All right, so the prime factorization of 30,031 is just 59 times 509. I hope you found this video helpful. If you did, please remember to give it a thumbs up. If you like the video, that'll help other students to find it.